So, our next talk for the day is going to be Tomasz Woźniak from Next STX. He's going to do actually live coding, which is very brave. And wish him luck and give him a big round of applause. That works.
Okay, hello everybody. I'm Tomasz Woźniak. I'm working STXNext. I'm Python developer, and our client is Optimat. They are managing a media trading video in UK and Ireland, and we built for them the Copy Central, which is the clearance media platform especially for UK. And among others, we handle complex workflow, a large file uploads, and the last point is very important because we built 24 hours end-to-end tests, and this is still growing. And today I will try to say something about behave scaling. So why it takes so long? This is the main question I will try to answer. Basically, end-to-end tests are slow because there are many layers that communicate each other, especially browser and WebDriver. And the second point is a very large number of scenarios. I would like to extend this first because, do we really need this? Sometimes tests are slow because basically people don't know how to use it properly, and there are a few tips, like maybe it's not a good idea to put more complexity into your test framework and try to think about parallel run. Maybe there is a place for improvement before you put your mind on parallel. So, few points. Wait for event, don't use time sleep, use reasonable scenario outlines. In BDD, each example will be executed like a separate scenario. Write non-GUI BDD test, maybe not always using Selenium is necessary. Maybe you could use just BDD without Selenium. And there are a lot of more points that you should give a try before you think about parallel run. But if let's assume that you did everything you think you could, and we think we did, 24 hours of end-to-end testing is crazy time, and this is something that we wanted to avoid. And I will show you today an example based on technology stack on presentation. Cool. Okay. It's of course Python, Behave framework written in Python. On today's examples, I use of course Python 3, Selenium and WebDriver. Of course, we will need a browser and Docker as tool, which will help us make it happen. So before I start, I should say something about behavior-driven development. And apart from this great advantage of it, like writing tests before functionality, we got the closed structure like on the slide. This is the example of feature file. We can see feature which contains scenario. There can be multiple scenario, and scenario contains steps. This helps us, and this gives us actually to manage this and divide it in individual units, which will be helpful in splitting it into different processes. But before everything, we should assume that we will prepare properly to scaling test. The first point is that we should have scalable environment which we're going to test. It will be really bad if we end up, when we put some time on scaling our test, but we will end up with our application will be basically the bottleneck. So if we want to scale test, we should be able to scale our platform as well. The second point is independent scenarios, which means that each scenario should be independent. So each scenario cannot rely on different one. We should use separated data because we wouldn't have enough control of order of executing scenarios. So it means that we should treat each scenario like individual unit can be executed in any time. And the last point is important in our case. This is the fixtures. I believe lots of you are using fixtures in your tests. And usually end-to-end tests or Selenium tests are executed on some working system like UAT. So it's really bad if tests are failing because of broken data. So as example, we use users and for example, we have client which clicking on the system and change user password, and our tests are failing in the middle because this password is not correct. So we built some kind of tests for tests, and we executed before each run on end-to-end tests. Basically, we use Python request library. We send bunch of requests to our platform, and we validating if all data is properly. It takes around 30 seconds, and thanks to that, we are sure that all fixtures that we are going to use are set up. Okay, so I divided this whole test framework into 3 parts. Each of this should be scalable. First is browser, second is Selenium WebDriver, which will control the browser, and Python environment, which will control the rest. So each point should be individually scalable. And like I mentioned before, Docker will help us to make it happen. This is a concept of scaling Selenium browsers. This is the diagram from official documentation. We can see 3 nodes with Firefox. These are basically the browser, and Selenium Hub is kind of load balancer. So we use one endpoint from our Python behave framework, and we call only Selenium Hub, and Selenium Hub will redirect all traffic to each node. So this is kind of diagram. I seen this specification built on physical machines, so it sounds like wasting resources. And this is something that we are going to build on Docker containers. So when I said Docker containers, some of you probably think about Docker Compose file. This is something which will help us to spin up everything in one configuration. And this is something what actually I pulled from Selenium Docker registry. So this is exactly copy-paste from documentation. And there are available 2 browsers. One is Firefox, second is Chrome. I use only one for this presentation because I would like to have one browser connected with one worker. Probably some of you are thinking, how about Edge or Safari? This is not Dockerized, and if you really need this browser, probably you need to consider some cloud solutions like Browser Stack or something like this, but it will be really expensive. Let's try it. So I will execute this Docker Compose file. It is visible? Okay. So at the bottom you can see 2 containers working, and this is first is Docker Hub, Selenium Hub, and secondary is just Firefox. And I will go to Selenium GUI, and we can see there is one browser ready to be used. So let's scale it. I have added 8 Firefoxes. And we can see 8 containers are running on the bottom. And I will refresh the page again. And yeah, we got 8 ready Firefox on my laptop. And basically, basically that's it. That I just resolved 2 of 3 problems here. And actually, I didn't write any code. I just pulled the configuration from Selenium documentation. The third one is more tricky because currently in Behave, there is no feature like scaling or run in parallel. So we need to figure out something our custom. But before we go with that, we should just think about the main problem, how we are going to divide scenarios to individual worker, to individual process. So the first idea was that let's maybe count steps, and based on that, we will assume that if one scenario has 5 steps, it will execute with 5 units. And we end up with something like this. It was really naive because each step is different. Each step can take a different time. Of course, each step has different goal to achieve. So in this example, we got worker 2 that finished its job in the middle. And basically because that we assign these scenarios to worker 2 by at the beginning, we cannot let him work later, so we are wasting resources here. This assumption was really naive. So the secondary approach that was, because Behave framework allow us to control logic before and after scenarios. Basically there are hooks. We can execute some code before, after, or before everything and after everything. So maybe we could create some microservice where we could store timings, the real timings. We can calculate time when we started and the end, and based on that we can calculate scenarios based on real times, and it should be something like this. It doesn't matter how many scenarios are in one worker, but we rely only on real timings. But what possibly could go wrong here? The retry. So what is retry actually? This is not something explicitly implemented in Behave, but it's really helpful to keep test in positive state, let's say, because it's very often when Selenium fail on some unexpected scenarios, on randomly failing, people saying that. It's actually not true. Usually it's because people don't use it properly, don't waiting for events or expecting something before it appears. And this retry can a little bit help that keep this build in healthy state. I mean, after retry, Selenium can find this missing element and everything can be fine. But this is only a workaround. This is not a solution. But retries are useful to keeping everything in real state. We would like to avoid false negative because it makes people that people don't treat it seriously. If people see red build every single day, people don't look at it in the file. So we came up with the first solution, and this is something like we use right now. So we drop assigning scenarios at the beginning. We take all names from repository, and we put this in queue server, and then we pull scenarios from queue server and we executing until last message. So thanks to that key, all workers will work until the last message. So it should be something like this. It doesn't matter how many workers we have. It's up to us actually. We can add it in the middle of the run or remove it. Also, we don't have to maintain workers on one machine, and can be split into even in Amazon container service. So scenarios will wait for execution, and workers will be pulling this from the queue. But for this solution, we will need more containers. And as example, I found a ready image of Docker RabbitMQ. This is something that I can pull like Selenium images. This is the broker which will handle messages, and our one message will be simply scenario name. But we got broker and we will need worker, and I choose Celery, which is a really cool tool. Probably all of you are familiar with it for asynchronizing task executing. And this is the sample of Dockerify. This is the first code that I've written here on the slide. We can observe only a few lines. Basically, it's installing requirements and run Celery worker. What is worth to mention that I changed concurrency to 1 because in default it depends of your threads in your CPU. It's 4 or 6, but I would like to show you that one worker works with one browser. Okay, let me show you this. I stopped previously created containers. I will switch branch. So basically, I added new sections in Docker Compose. I will show you it right now. And we can see there are a few containers working, 2 previously created and 2 new. One is RabbitMQ and one is worker, like expected. And I'm going to explain what I'm going to do right now. So this is my Docker Compose with extra sections, RabbitMQ and worker. This is a simple bash file which will take all scenario names from our Behave framework and put it in RabbitMQ. And I created 2 sample of feature files. Here we can see 3 scenarios. And here there are 4. This one, deleting user will fail. This is expected because I would like to show you the output of it. And this is an example of scenario outline. This is something that I mentioned before. Each example of this will be executed as individual scenarios. So we are going to divide this an outline to separate run as well. So I expect to run around 8. It should be 8 tests. Let me show you logs on this console. I believe it's not real visible, but I will show you something better later. So let me run a test right now. And it will print out scenario names. We can see the outlines was divided into 2 separated scenarios. And we can see one worker actually right now is working. And the average time of each scenario is around 10 seconds. So we would need wait around more than 1 minute. Meantime, we can look on the statistics. We can see the high consuming memory is, of course, Firefox. I have calculated this on a real system, and the average is between 500 megs to 700. So quite a lot, but this is still something to be really scalable in cloud solution like Amazon. Okay, so let's have a look about on this test result. There are a few passed. We are waiting for this failure, which is supposed to be at the end. Almost there. Yeah. And we got this failure. It looks like that. This is the only log, so this is not good to read right now. Yeah, let me scale right now our workers and browser. Oops. Okay, so I need an additional scale parameter. So here we can see scale Firefox, scale worker, maybe, oops, maybe it's not visible. Maybe now it's better. Okay. So at the bottom, we should see Docker statistic. We're running 16 containers. And we'll execute tests again. Because I have 8 workers and 8 Firefoxes, I expect the result maximum 15 seconds, maybe 20. Because there is a little delay printing out scenario names here, but it can be limited. I mean, we don't need to print out it in production, so this is only for presentation. We can see in our Docker logging that all workers are working and all results we got immediately, apart from the last one. Yeah, it was around 20 seconds, let's say. Yeah, 20 seconds. So I actually presented you the scaling from 80 seconds to 20 seconds. So it's not that just like divide for threads, because there are always some delays. Okay, but like you see, reading of this is not really cool. I would like to report it somehow and keep it as Jenkins artifact. So for reporting, we use Allure. This is something supported in Behave. This is actually separate Python package we need to install it and add one parameter to Behave run. And basically it will generate this kind of JSONs in your home directory, in your repository directory. And after one command, it will redirect us to this kind of GUI. This is the HTML report, it can be assigned to Jenkins, and it will grab everything into one report. It doesn't matter how many processes are we using, it will be presented like one single run. And we can see 2 feature files here, and there are one feature file contains multiple scenarios, and here we can see steps and time of execution of each step. Here is the red which failed, and we can see bomb icon here. It means that the test is flaky, so we have more than one result here, and this is an example of retry. So first retry just was passed, but secondary will fail, and it marked it as red with bomb icon. It means that we should something do with that. It's not stable test. Okay, but this is only reporting tool. We would need something more because there are a lot of things happening in the background. So I would like to see what exactly going on there. If something is not right. So we have 2 options, and this is probably we get more, but this is totally enough. One is RabbitMQ control. This is command available in RabbitMQ container. We can monitor queues there basically, and we can connect it to our dashboard or anything. And the first one from the list is celery flower. This is something that I'm going to present to you right now. So I stopped all containers. Logging will finish. And let me change branch to step 3. And we'll re-execute our containers. And go to celery flower GUI. It looks like this. We have to wait for our workers are connected in broker. So I will keep refreshing. Loading. 'Cause, 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 'c Oops, let me try workers are there. Yeah, we got 8 workers waiting for our task, and this is the tool which can be useful for monitoring. I'm going to execute test again. We don't need logging here because we will look into Flower. So I executed 8 tests, and we can see this is immediately updated. Each workers take 1 message. All are processing at the same time. And yeah, in this GUI you can see the actual scenario names. When I refresh it, we should see some success and 1 will fail. The result pass means that test pass, of course, but 1 with fail will not have the result because it's not possible to fail with result in Celery. So what we would need here is something go wrong. Of course, traceback, it's here. Full traceback and actual scenario which failed. And maybe it would be useful to attach some screen, but it's not implemented yet here. What next we have here, we can use this monitor it's actually something ready to present on our screen, but probably we won't see anything because it will be immediately start here, so we'll execute test again. So we got 16 messages here, so we should see some graphs soon. Yeah. So this graphs present a succeeded task, failed task, and queue task. Queue task just means that we have more messages than workers, and this is something which could be used for monitoring how many time we need to spend on test, or what is the ATA for this. Yeah, 1 failed. It's correct. A secondary failed because I ran it twice, basically. Okay. So summary. In our platform, we reduce time to 1 hour, and we use 32 parallel processes. And it cost us only for browsers, of course, workers and web drivers, in AWS 50 cents. Yeah, so quite cheap. We execute production smoke testing on Behave. Thanks to time executing, we can do it faster and validate it after each release. And we agreed that no test, no match, and it's related with our Behave repository and Python, which we run on our platform. So because we are able to validate each change in 1 hour, it can be improved. But in our case, the system is bottleneck. So the 1 hour is totally acceptable here, because basically we can validate the whole workload by that. So I'd like to repeat the keyword, scaling. You should be able to scale your application if you'd like to scale your test. And at the end, I would like to share 2 pro tips. So the first is find top 5 longest scenarios and fix them. Scaling won't help you if you end up with the last scenario will be executing 30 minutes or something like that. I will suggest to keep maximum 10 minutes. Maybe it's still too many time, but 10 minutes is totally sufficient for us, and this is something that even if the last scenario will be executed at the end, this is only 10 minutes. Yeah. And the second tip is to find top most often repeated tests. It will be visible in our as bump icon, and fix them. Repetition of tasks or scenarios is only workaround. It's not solution. And that's it. Thank you.
Okay, works. Thank you very much, Tomasz. You have 15 more minutes if you want to answer some questions.
Yep. So the first from top, have you tried also other solutions than Selenium Hub, Selenoid? I have not, so cannot say anything. We can talk about it later, afterwards, so I can resolve it. Maybe I will try. Second question is, have you tried wrapper of Selenium like Splitter or even better PyTest Splinter? No, I have not as well. I invite authors of these comments after this talk. Maybe we can talk about it. How did you solve the timeout problem, especially in cases where you cannot use retry, like creation of deletion of an object? I'm not sure if this is timeout related with browser, because the timeout of browser can be set on Selenium itself, and there's an API, you can control it. There is a known problem that sometimes browser hangs without any response. This is something that we also manage, and we basically kill browsers and we retrying test them. But I'm not sure if I understand this, like creation of deletion of object. And this, I mean, probably it's related with long running of applications, something like that. So if yes, I will say...
if it's a question from the audience, maybe someone could clarify it.
Maybe someone can clarify.
Raise your hand and I can give you the mic. Or maybe it's from the live stream.
Okay, so basically, like I presented on slides, we are trying to wait for events, not for, we don't use timeouts, so it will wait for event. If system is loading too long, we basically failed because we expect it like to be failed. Yeah. Why introducing another level of abstraction with behave when Python code can do the same with PyTest with more flexibility? It's all because you can split it on multiple containers, which means it can be executed in multiple machines. So if you use AWS, you can use ACS service and keep it and scale it when you need. So yeah, this is another complexity abstraction. I agree with that, but it has some advantages for us.
Okay. Thank you very much, Tomasz, for the talk.
Thank you. Hello, I'm Tomasz Woźniak. I already finished my talk. I would advise everyone to be part of it because it's really great to share your knowledge and take from the other speakers. Thank you.